Next, we will discuss about what are the static members we have in our Java, and we will see static members control flow, how it is executing inside all static members like static variables, static blocks, static methods, and main method. All this comes under static members. We will see how all these types are executing in our JVM internally. First, we will make a note about this. Static members and their control flow. So, what are static members? We will discuss now. First, I will make a note about this. What comes under static members? The member which is created outside of a method at class level with static keyword is called static members. The member which is created outside of a method at class level with static keyword, then those members are called static members. So we will discuss what are the types of static members we have in our Java classes. Types of static members. Java supports 4 types of static members. What are those 4 types? First one, static variables. Next we have static blocks. And also we have static methods and main method. All these 4 types comes under Java static members, static variables, static blocks, static methods and main method. And when do all these members will get memory location? When all these static members will get memory in our JVM. We will discuss about that. All the static members which are identified, all the static members are identified and get memory location at the time of class loading by default by JVM in method area. All the static members are identified and gets memory location at the time of class loading by default by JVM in method area. We have seen internally in our JVM architecture classes. I will make a note about that. All static members are identified and get memory location at the time of class loading by default by JVM in method area. All the static members are identified and they will get memory location at the time of class loading by default by JVM in method area. First we will see how static variables will get memory in our JVM with program and JVM architecture. I will show you. First we will discuss about static variables, then next we will discuss about static blocks and static methods and main method. First we will discuss about JVM architecture with static variables. First I will create a class, then you will understand clearly. Class, some name, example, I will give example as name. This is my example class. Inside this class I will create static int a is equal to 10. This is my static variable. Static int b is equal to 20. So these are my two static variables, and I will create main method public static void main string array args. Inside this main method I will print those static variables system.out.println a. I want to print this a and system.out.println I want to print b. This is my b variable. So what I have done here is I have created a class with two static variables and I have created main method. This is my main method. Inside main method I am printing my a variable and b variable. Static variables I want to print. We will see how this program will be executed inside JVM. Next, we will create JVM architecture. This is my JVM architecture. Inside JVM architecture, we have method area and we have heap area and we have Java stacks area. This is my method area. This is my heap area. And next we have Java stacks area. So when our class is loaded into JVM, when we execute our class by using Java command, Java example, then this class will be loaded into method area from our class loaders. We have discussed all these topics in our JVM architecture. Then this example class will be loaded into my method area. Then whatever the data we have in our example class will be stored in this method area. My A variable and B variable. And whatever the data we have in our A variable, first it will store default values. After that, first it will store 0 default values of our variables. After storing default values, then here it will store my main method string args. Next, inside Java stacks area, one thread will be executed. Which thread? By default Java stacks area have main thread and garbage collector thread. We have discussed about all this. Now we will see execution of main thread in Java stacks area. This is main thread. Inside main thread, a stack frame will be created for my main method. We have discussed for each method one stack frame will be created inside a thread. So inside main thread, one stack frame is created to execute my main method. Then my main method execution process has been started. Inside main method, first we are printing a value and b value. Then when it comes to main method, it will initialize my static variables with its values 10 and 20. Then this 0 will be replaced with 10. That will be stored inside a. Next, the 0 will be replaced with 20. And it will be printed on our console. This is how our static variables will get memory in our JVM architecture. Next we will see JVM architecture with static methods execution flow. How static methods will be executed in JVM architecture we will see now. JVM architecture with static method execution flow. So when a static method is called from our main method, first JVM will create stack frame in our main thread. Already we have seen this in our JVM architecture example. Again I will explain you clearly. When a static method is called from our main method, JVM creates stack frame in our main thread for the execution of that main method and loads that method complete logic and executes line by line of that method logic. The stack frame is destroyed immediately after that execution is completed. First I will make a note about this, then we will see practically how it will work. I will show you. All these explanations I am explaining what is happening internally. That's the reason I'm not explaining these programs in our I'm not executing these programs in our command prompt because this lecture is about understanding internals. To show you the internal part, I'm explaining all this. Already we have executed all these classes, example classes in our variables and types of variables and methods and types of methods. Next we will see. So first I will make a note about this. When a static method is called from main method, JVM creates stack frame in main thread, then loads that method complete logic and executes line by line of that method logic. Then the stack frame is destroyed after method execution is completed. This is about static method execution in our JVM architecture. We will see how it works. First I will create a program, some class sample program. So in this class I will create some static methods. Static void m1 static void m2 static void m3. These are all static methods in my class. Inside this I want to print system.out.println. Inside this I want to print m1 because that is m1 method. In m2 method I want to print system.out.println m2. Next in m3 I want to print system.out.println m3. I will call all these methods from my main method. Public static void main. String array args. Inside this main method I want to print first system.out.println. I want to print main. Next I will call m1 method and I will call m2 method. Then I will write system.out.println main. I will write this as main end. This I will write as main start. We will see how this program will execute in our JVM. So in this we will create some variables. In the static m2 I will create some variables like int m is equal to sum10 and int n is equal to 20, and this mn same variables I will create in main method as local variables to our main method. Int m is equal to 50 and int n is equal to 60. We will see how this program will be executed. In m3 also I will write int m is equal to 20, int n is equal to 30. We will see how this program will be executed line by line in our JVM. This is my Java class. Now I want to show you this program execution inside JVM. This is my JVM architecture. Our JVM architecture consists of method area, heap area, and Java stacks area. This is my JVM architecture. My JVM architecture consists of method area, heap area, and Java stacks area. So what will happen when our program is executed? First, when this class is loaded from our class loaders to this method area, we have discussed all this in our JVM architecture. This class will be loaded from class loader to our method area. Inside our method area, our class data will be stored inside method area. This is my class data in method area. My class sample consists of m1 method, m2 method, m3 method, and main method, string array args, string array args. These are the methods available in my sample class. So whenever execution starts from main method inside Java stacks area, our main thread will be started because it is default thread. We have already discussed about that. Main thread. When main thread starts, it will create a stack frame inside main thread to execute my main method logic. For each method, it will create one stack frame. Please don't forget that. That's the reason I am always explaining to you. This is my main stack. Main stack. My main stack consists of two local variables. What are those? First, when control came to main method, it will print this system.out.println main start. After printing main start on console, it will execute line by line. When it comes to line by line, next we have m1 method. Then control goes to m1 method, it will print m1. As we have written system.out.println m1. Next control comes to m2. m2 method, then control will execute m2 method, it will go to m2 method. Inside m2 method, we have written m2 in system.out.println. This m2 it will print on console. Then I have created two variables, int m is equal to 10, int n is equal to 20. So for m2 method also, it will create for m1 for m2. For all these methods, stack frames will be created. This is for m1 method and this is for m2 method. This is m1 method stack and this is m2 method stack. Inside M2, we have two variables M and N. This M and N will be stored inside this M2 stack. Inside M, this 10 will be stored. After that, it will create N. Inside N, it will create 20. Will be created inside N value. Next, after executing M2 method, we have two local variables in main method. This M and N is local variables to my M2 method. We have discussed in our variables and types of variables topic that local variables will be destroyed when control comes out of this M2 method. So M is equal to 10, N is equal to 20. It has created M and N variables with values inside M2 method. Then control came out of M2 method. Then this M is equal to 10 and N is equal to 20 will be destroyed. After that, control comes to M is equal to 50 and N is equal to 60. This M, N values will be created inside my main stack. M inside M 50 will be stored. Next, it will create N. Inside N, the 60 will be stored. After main method execution has completed, after N is equal to 60, N is equal to 60 stored in my main stack, then control comes to system.out.println. Main end will be printed on my console. Then my main method execution is completed. That means these local variables will be destroyed. This is how our program will be executed with static methods. Next, we will discuss about static blocks. Static blocks. So, we have seen what are static blocks in our JVM architecture examples. Static block is a class level nameless block it is that contains only static keyword in its prototype. We have created static block in our JVM architecture example. Now we will see how to create it and how JVM will execute the static block. I will make you understand clearly about this static block. First, I will make a note about this. Static block is a class level nameless block that contains only static keyword in its prototype. Just static keyword will be there in that prototype, and it is a class level nameless block. I will show you the example. I will just create a class, some class example. Inside this class, I will create a static block. How we will create static block? Just you will use static keyword. Just static keyword and inside body. This is a static block. Only static will be there in its prototype. This is a static block. Whatever the logic you write in static block will be executed in JVM. I will show you how it will execute in our JVM. Inside JVM, we have method area, heap area, Java stacks area, PC register, some native method stack area. So this static block is executed in our, this is my JVM architecture. This is my method area. Heap area. Java stacks area. PC registers. Native method stack area. These are the components of my JVM architecture. The static blocks, whatever the static blocks you write in our classes, that static blocks will be executed in my Java stacks area. First, in Java stacks area, by default, main thread will be created. From the initial classes, we are discussing about this topic. This is my main thread. Inside main thread, it will create a stack frame to execute main method. But whenever in class, if you write static block, either one static block or two static block or three static blocks, before executing our main method in our class, this static block will be executed. This is the most important point in static block. Whenever class is loaded inside JVM, before executing our main method, this static blocks, whatever you write, you can write hundreds of static blocks. Before executing main method, this static blocks will be executed first. For one static block, one stack frame will be created. This is my stack frame for my static block. After executing static blocks, then control comes to main method. Main method logic will be executed by creating another stack frame. This is how static block will work in our Java. If you have two static blocks, before executing our main method logic, static blocks will be executed by creating two static two static stack frames. This is how static blocks work in our Java. So what is the need of this static block in our Java? We will discuss now. Need of static block. What is the need of this static block? This static block is used to execute logic only at the time of class loading. Means like initializing static variables. In the JVM architecture examples we have seen, I have created int a is equal to 10, int b is equal to 20. There I have initialized my static variables by using static block. Then my AB will be inside my AB memory, that variable's value is stored. Like that we can initialize static variables by using static block. And also static block will be used for registering native libraries. And also it is used to know the classes loading in order. We will make a note about this. Our first point is initializing static variables. Initializing is nothing but giving some value to that variable. Int a is equal to 10, that is initializing. Suppose if you declare int a, that is declaration. You did not initialize that value. If int a is equal to 10 means then 10 value is initialized to your a variable. Next, registering native libraries. And next, to know classes loading order. So this is the need of static block in our Java. We have seen how to create static block in class, and we have seen execution in our Java stacks area. Next we will discuss about our main method. Next we will discuss about our main method in Java. What is the use of main method and what main method is doing in our class, we will discuss now. Mainly, main method is a calling statement. This main method is a calling statement in that JVM software. Inside JVM, this method call is there. This main method is called from our JVM. If JVM is calling my main method, then my main method will execute or not. That's the reason whenever JVM process starts, then my main method is called from my JVM. Then after calling from my JVM, this method will be executed. Like how we execute our own methods, like that main method is called from JVM, then main method is executed. And you may get a doubt like why static methods or non-static methods which we write is not called from our JVM. Because our static methods calling statement is not available in our JVM software. Only main method calling statement is available in our JVM software. Because JVM doesn't know your method's execution order, which method to execute. You will know which method should execute at what time. JVM cannot know. Just JVM is giving you a roadmap where to go. You should do your journey. Like that, JVM doesn't know your method's execution order, and also it doesn't know what are the methods should be executed from your class. It is a developer responsibility to inform methods and their order of execution to JVM. That's the reason for that purpose there should be a common method, right? That common method is nothing but a main method which is given by JVM. So we will make a note about all these points. First I will show you the example. I will create a class. Class example. This is my class. Inside I will create static some void m1 method. And I will create public static void main string array args. This is my main method. Inside main method I will call my m1 method. M1 method is having some system dot out dot println. Some m1, it is having m1. So how this main method will be executed inside JVM, we will see now. This is my class which is having a static m1 method and main method. And this is my JVM. Inside JVM, whenever you create a class with a name and whenever you create main method, what will be happened is by using your class name example by using your class name dot, it will call this main method inside JVM. This main method will be called from my JVM by creating string array object. Array index will be starting from 0. This is how JVM will call my class example main method from my JVM. If you create sample class, then JVM will call class name with main method sample dot main new string array. Then this sample class or example class dot main, this main method is called from JVM. Then from main method we have to call our own methods to execute our own logic. But JVM don't know our own logic when should execute, where should execute. It is giving a roadmap like main method. It is saying that I will give a method, you have to write method calls which method should execute. Then JVM is saying I will call those methods which you call from my main method. That's the reason inside main method we are writing our own methods. When JVM is calling our main method, from main method our logics will be executed, our methods will be called from my JVM. This is how execution takes place from main method. Main string array.